All right, so since we are kind of like just covering a little bit of HLSL there, I'm going to show you just really quick built-in shaders here. Let's see, let's just extract this. Cool, and I believe it's in, let's see, let's just look for it. Skybox Panoramic. So the original Skybox Panoramic shader has this rotation value. Hopefully everyone can see this. Yeah, so this rotation value is the one that we really wanted to work with. So, yeah, I should be able to. Oh no, you're good. I don't know why my.
I think you can shift select and then hold shift and move your.
Yeah, that's what I'm trying to do. I'm trying to hold control. Yeah, that's that. I've been doing that like my whole life, and yeah, it's oh well, that works too. That'll do all of it. Can y'all see now? Yeah. Is that better? So the rotation value was the one that we really wanted for the rotation, but we don't want to apply it to the original Skybox. We only want to apply it to the overlay. So the actual, yeah, so it's the tint color. This is the color. Then we have the main text. That's our main texture. So what you want to do is you want to duplicate that, and you can name this something like overlay texture. So before I save that, let me just show you the actual first one, right? So let's actually rename this to something like URP, Skybox, whatever. Let's see. And if I create a new material, Skybox, URP, and custom, oops, it's in URP, Skybox. Okay, panoramic. So spherical has one slot here. So if you go into your HLSL code, and if I added this overlay texture, and if I save that, let's see here. Oh yeah, one last thing. So really important, a lot of these Unity created shaders, or just in general shaders you'll find in packages, they have these custom editors. So the custom editor, you can actually just safely comment that out. If you comment that out, you will get all your input values out. So a lot of times if you do edit your own shaders and you're adding all these input fields and you're adding all these floats and booleans, you're like, where are they? Why aren't they showing up in my inputs? It's probably because there's a custom editor. So let's see here. What you want to do is create another overlay texture, and maybe something like a speed texture. So let's see, speed, rotation, speed. This is just a name. You can be called anything. And we could do a float equals 0.1, let's say. So that will be our speed value, which is rotation speed. And in your actual subshader, so right here is where you're actually defining in C the actual values that are going in. So you kind of want to just follow the pattern here of main texture, overlay texture, oops, and that's a sampler, and then you have float, and we called it speed. Was it capital or, oh, it was, yeah, like this. Float speed. So those are defined, and let's see here. So now you could probably pass most of this stuff to cube coordinates is there for if you're using a cube map. We're not. We're using a equirectangular panorama. There's the function for rotation, which we're going to basically reuse, and our app data. So our app data we'll get back to in a second. I believe we have what we need here to get to the fragment shader. Okay, so the fragment shader is where we're actually going to be multiplying our textures, and I'll explain it in a second here. So your vertex shader is where your UV mapping happens, where your vertices, matrices get edited, etc. Anything that you saw, like for example with the wave shader, that was a vertex shader. What you saw with the actual waves in the normal maps, that was a fragment shader. And you could see that here in the graph. One plugs into vertex, and the other plugs into fragment. So it's very visual like that, so you could see it. But if we look at the vertex shader here, and if we just look at our rotation here, so our rotated values, yep, it's right here. So the change was added, just to remind myself. So it's a duplicate of rotated, but the only difference is there's rotation that adds time times rotation speed. So what you do here is you copy this, and what do we call it? Overlay rotated. Okay, so it's rotation times time times speed. I believe that's correct. Yeah, we had it called rotation speed, and time is in the Y here. And the last part is we have to then output it. So what happens is your vertex shader has inputs, and then the vertex shader outputs to the fragment shader. So it's kind of like a one-way street like that. So the output here, what do we call it? Yeah, let's call it text chord 2, for example. That's totally fine. Equals to overlay rotated. We can do that, just to pass it along to the fragment shader. Now, the text chord, let's just call it text chord animated, so it's not confusing here, because what we need to do is, in the shader, you have these text coordinates that are very strictly assigned. So if I have text chord is assigned to text chord 0, text chord overlay, I think we called it text chord animated, yep, just making sure we got the right name, needs to be, let's say, set to 1, but we already have a text chord 1, and if I go back to Unity, it'll kind of yell at me and be like, hey, you double defined text chord 1. Now do keep in mind that HLSL is basically C, so if you make one mistake, there's no debugger, it's not going to tell you, oh, you did something wrong, it's just the whole program is going to fail. Yeah, but it will tell you, there is a bit of a debugger, and it will tell you probably the line where you messed up. But what I'm going to do is, since we want to use text chord 1, I'm just going to inch up text chord 1 to 2, 3, 4, 5, and 6. And this is on an else, so it technically will not mess with it. And I believe that's all we need to push it out. Let me just see if, yeah, we had a duplicate for text chord 1. Let's see here. Did we actually just 2 and 3? 2 and 3. Cool. So it's not pink, which is a good sign. Whenever it's pink, that means there's a bad shader there. So now down to our fragment shader, and this is where we get down to business. So this is if mapping 6-frame layouts. So what do we have here? Yeah, we have basically the text coordinate, and we'll take TC overlay. I believe we called this one text chord animated. Let's see if our shader still compiles. Looks like it does. And so let's see here. Our final value is going to be the color. So right here, you could see color is a half 3, meaning RGB. So you could have float 4 or like a half 4, which has an alpha value as well. In this instance, there's no transparency on the skybox, and it's a high dynamic range image here, so it only needs a half-3. And C is short for color here, but what we can then do as well is we can take, let's just double make sure that we got that the right way. Yep. So create another half-3, call it C2 or C overlay or whatever you want to do, and see and just make sure that we got, yeah. And we got to also unpack it. So we're going to take text overlay here, and that's going to be our overlay texture. Yep. And our TC animated, I believe is what we call them, right? Or TC overlay. Yeah. So we're unpacking it, and then we're going to decode it in the same way. Now this. And oh yeah, one more thing is important here. It's going to be overlay text. We have to define the HDRs as well. So you have main text, overlay text, main text textile size, main text HDR. So you create a half-4 here for the HDR and call it overlay text HDR. And did we also need the textile? We did not need that. I believe that should be our fragment shader. And just to test this, we can actually take the final value is equal to, let's just do a quick multiply, and I'll show you how you can actually do an overlay. So, and we're returning that. Let's put that in a skybox so we can see what that looks like. So this is our new skybox. This is our main texture, and then this is our other texture. Now you can see that they're overlaying by multiplying, but what we want to do is we kind of want a screen effect. We don't actually want to do a multiply because the clouds need to be brighter, so they need to kind of be on top. So if you do any kind of image editing, you know how you have blend modes, you have like overlay, multiply, difference, etc. So those are just really simple math formulas that you can actually do in a shader. So I believe, I'm going to try to do this one off the top of my head. It's basically the inverse. It's 1 minus the inverse of each multiplied. So it's 1 minus C times 1 minus C2, and that should be an overlay. There we go. So that's a formula for overlay, if you're curious. But yeah, and then if I recalculate lighting and all that stuff, everything here will go. Now, I believe the last thing that we're missing is our speed here. So what's going on with, why aren't we rotating? Oh, because we were using, I think we were using the original rotation value here. Probably needs a little bit more tweak in that vertex shader, but let's put that rotation speed back to where it needs to be. But yeah, that's a simple way to tweak the skybox shader. I find this effect to be pretty good. I see a lot of people using very static skyboxes, or they use some pretty expensive assets to create like dynamic clouds and all that. But again, mind you, this is all URP. So this could run on an iPhone or an Android or in VR or pretty much on any platform. You probably want to keep your skybox textures to 4K for mobile, but if you wanted to make 8K and if your platform doesn't allow it, there are ways you could stitch together multiple 4K skyboxes if your memory allows it, if you want to get over that limit and kind of position them in each quadrant, you can call it. Cool. There is, let's see, I think that was pretty much what I had for URP. I had a toon shader, if anyone's curious how toon shaders work. And that was like a pretty quick one. I believe I have it. And so I got a little character here. Yeah. So we're gonna put Elvis in here. And he's just gonna be jamming. So I'm not gonna put the animator on him or anything like that. We can if we feel like it. But let's see. So we had our toon shader here. So let's create another material. And let's put in our shader graph, toon shader, and there we go. So, and then we need a ramp, so a toon ramp. So, and I'll show you all how this works in a second. I could just come with good old paint here. And let's make a very simple toon ramp. Oops. Oh, and want to fill. There we go. Actually, this should end with black here. Oops. Slip of the finger. There we go. And we want a gray one in the ramp. There we go. And that's our toon ramp for a toon shader. So let's call that there. Toon ramp. Pull in that. And so it's a little bit of a toon shader. It can have a Fresnel effect, Fresnel threshold, and you know, whatever color you want to set here, you can. And the toon ramp is basically how many kind of sets of colors you want it to have. So the toon shader is actually a really simple one. And Fresnel is actually really simple to do in shader graph as well. So it's called a Fresnel effect node. You could step it a bit, set a maximum, and what you're actually doing is you're taking the normal vector. So that's why when you look at the character, the angle that you look at him from, you notice that the shading changes. Now, it does also get affected by lighting. So in this instance, I'm not really sure where our light is, but let's see. It should be affected by the light here as well. Yep. So you can see that the effect does react to lighting because the toon shader is actually taking into account where the lighting is coming from, and it's doing that from, where's that node? Main light direction, yes. So the main light direction is the dot product of main light direction and normal vector goes in there, and it gives you a little bit of a toon shader. And yeah, well, maybe we can make them dance. Because why not? There we go. And Mr. Elvis. Animation, loop. There we go. Cool. Yeah. Oh, it's just it's a mixed amino acid. it had the animation on it. I just had to add a animator controller to it, and it had the animation in the FBX file itself. But yeah, he's just jamming. Now, URP obviously has its limits. You know, we probably really want to see like some reflections here. We'd probably want to see him like reflected in the water. We'd probably want to see a little bit better lighting. There's a little bit of a shadow going on here, but nothing's happening on the water. He does kind of look like he's floating. Oh, I can't even grab you, buddy. Gotta grab the actual parent object. But yeah, it's hard to tell. Oh, come on, stop moving. It's hard to tell where he is until he kind of actually kind of goes in the water. A reflection would help a lot with that. And that's where HDRP comes in. So, yes.
How do you see where his feet are hitting the water?
Yeah.
How do you shade mesh around that to get the water inspection?
Yeah, that's a great question.